right, so today's lesson is lesson 1-3, which is factors and multiples, and we're only going to concentrate on the greatest common factor today, okay? Now, in the con video, the guy talked about the prime factorization. Prime factorization is when you multiply prime numbers to get another number. Is everybody with me? Okay? So, we are going to first write down the definitions, these definitions for each of those terms. Okay? We have the factor, and factors are numbers we can multiply together to get another number. So, for example, if we had, let's do 14, for example. 14, we can multiply 1 times 14. We can multiply 2 times 7. Those are factors of 14, okay? Common factors. Common factor is a number that is a factor of 2 or more numbers. So let's say we had 16, and we have 1 times 16, 2 times 8, and 4 times 4. The common factors that we have here are, of course, 1, it's common to almost all numbers, and then 2, and that's it. Okay, so the common factors are 1 and 2. The greatest common factor is the greatest of the common factors. So here, the greatest common factor of 14 and 16 would be 2. So here, this is still in the intro, we want to list the factors of each number. So for 12, what numbers can I multiply to get 12? I like to start with 1. So you've got 1 times 12. You've got what? 2 times 6. And you've got 3 times 4. Okay? So those are the numbers that you're going to multiply to get 12. Those are the factors of 12. So we say 1, 2, 3, 4, 6, 12. Those are the factors of 12. Got it? Now, here it says a group of 36 students are attending a science fair. At the fair, they divided evenly into 2 smaller groups. How many different groups of students can be made? Okay, so you don't need to write the whole thing. You can say, you can write down, we've got 36 students, and we can write down how many different groups of students can be made, okay? Or how many groups of students? Okay, so on this one, we're going to find the factors, okay, of 36. So here we've got 36. So we can break this down to 1 times 36. How about 2? 2 times 18. Good. How about 3? 3 times 12. Good. How about 4? 4 times 9. And 6 times 6. So here are the factors of 36. Now, we need to answer our question. How many groups? How many different groups can be made? Well, we can make one group of 36, but that's just everybody all together, right? We wouldn't really do that, but it's still a group, right? 2 groups of 18. See, 2 groups of 18. We could have 3 groups of 12. We could have 4 groups of 9. And 6 groups of 6. Now, you guys, we can also go in the reverse direction. We could say 36 groups of 1. But will we really do that? No, because that's just everybody by themselves, right? And then we have 18 groups of 2, We could have 12 groups of 3. We could have 9 groups of 4, and then the 6 and the 6 again. Is everybody clear? All right, so for example 1, we're going to find the greatest common factor by using factor trees and the cake method. We're going to do 2 different methods for finding the greatest common factor. All right, let's start with our factor trees. Just like in the video, we're going to start with 40 and 48. And we want to break these down until we can't break them down to any more prime numbers, okay? So, what can I multiply to get 40?
4 times 10.
We could do 4 times 10. Do I have to do 4 times 10? No, I could do 5 times 8. I could do 20 times 2, right? We don't want to do 1 because 1 doesn't change anything, right? Anything else? That's about it, right? Okay. So I'm gonna stick with the 4 and the 10. Are those prime yet?
No.
No. So we want to break those down some more. So 4 can be broken down to 2 times 2. And then the 10 can be broken down to 2 times 5. Are those all prime? Yes, those are all prime. Okay? 48, what can I multiply to get 48? All right. So here, 6 times 8, that's equal to 48. Are those prime? No, because we can break them down some more, right?
Yeah.
So what can I break the 6 down to? Yeah, 2 times 3. And the 8 we can break down to 2 times 4. Are those all prime? No, not yet. What else can I break down? The 4. The 4 we can break down to 2 times 2. Now, I don't want you to leave these up here. I want you to have one row of prime factors. So you're going to bring down the 2 times the 3 times the 2 and then times. Okay? So the last row is your prime factors. Is everybody with me? Okay. So now 40 is 2 times 2 times 2 times 5. 48 is 2 times 2 times 2 times 2 times 3. Right? And in the video, they asked you to write them with exponents. So, for 40, that's 2 times 2 times 2. What's 2 times 2 times 2? So it's 2 to the what power? How many times? To the third power. So that's 2 to the third power times 5. And then for 48, we've got 2 to the fourth power times 3. Is everybody clear? We have to multiply what they have in common, okay? So, do we have some 2's in common? Yes. We have some 2's in common. And do we have any 3's in common? No. How about 5's? No. So we only need to take care of the 2's, right? Now, the way we choose is we're going to choose the one that has the lowest exponent. So that's going to be 2 to the third power. Is everybody with me? Oops. That's going to be 2 to the third power. Now, let me show you over here just what I'm talking about. So you've got here, this is a 2 in common. This is a 2 in common. This is a 2 in common. And you see, there's nothing else in common. Does everybody see that? Mm-hmm. So, 2 times 2 times 2, that's 2 to the third power, which is equal to what? 2 times 2, 2 times 2 times 2. 2 times 2 is 4, times another 2 is 8. So the greatest common factor will be 8. So now I'm going to show you the cake method. We're going to use the same numbers. And when we use the cake method, we use 40 We use the numbers 40 and 48. And then we put a little box around it, like this. So that's the bottom of my cake. And then we're going to ask ourselves, what is a prime number that can be divided into 40 and 48? So, what can I divide into 40 and 48? 2. All right. So there's a 2. So now 40 divided by 2 is 20. And 48 divided by 2 is 24. And then there's another layer to our cake. Okay? I call it an upside down cake. You see what's happening? Okay? All right. Now what's another prime number I can divide into 20 and 24? 2. 2. So 20 divided by 2 is 10. And 24 divided by 2 is 12. And there's another layer to my cake. Is everybody with me? Is there another prime number I can divide into 10 and 12? 2. So this is going to be 10 divided by 2 is 5. And 12 divided by 2 is 6. Now, is there a prime number I can divide into 5 and 6? No. So now we are done. To get the prime numbers, the prime factorization, or the GCF, look at there it is. That's where we get our GCF. Is everybody clear? So, the GCF is 2 times 2 times 2, which is 2 to the third power, which is 8. So, for example B, it says there are 200 boys, 180 girls, and 60 teachers participating in a school field day. If the participants are divided into groups so that each group has the same number of boys, girls, and teachers, how many groups will there be? What's my important information? 200 boys, 180 girls, 60 teachers. Right. How many groups will there be? And we want the same number of boys, same number of girls, same number of teachers. Is everybody with me? Okay. So, that when it says same number, you guys, that's a clue that tells us we're looking for the greatest common factor. Is everybody clear? Because we're talking about the same, right? Same, common. Everybody clear? All right. So, do we want to do the cake method or the factor trees? Okay. I'll do the cake. I also did the factor trees in my written notes, and then I'll post that on the Canvas modules also if you want to look at that too. All right. So, we've got 200, we've got 180, and we've got 60. All right, and we want to do prime numbers, right? So what is a prime number that I can divide into 200, 180, and 60? 2, right? We could do 5 also, right? Could I do 10? You could divide 10 into all of them, but it's not prime, right? Okay, so you want to do 2? Okay. So 200 divided by 2, of course, is 100. 180 divided by 2 is 90. And 60 divided by 2 is 30. All right, there's another layer. What can I divide into all 3 of those numbers? Okay, so let's do 5. So 100 divided by 5 is 20. 90 divided by 5 is 18. And you guys don't forget, you are allowed to use your calculator to help you. And 30 divided by 5 is 6. Good. And there's another layer of cake. What can I divide into 20, 18, and 6? I think just 2, right? What do we say? 2. So 20 divided by 2 is 10. 18 divided by 2, 9. And 6 divided by 2, 3. And there's my next layer of cake. All right. Can I divide another prime number into 10, 9, or 3? No, because of that 10. So we are done. So to find my GCF, there it is right there, right? So the greatest common factor is 2 to the second power times 5. 2 to the second power is 4. Times 5 is, so we could have 20 groups. Is everybody clear? So now I would like for you to write those 2 vocabulary words in your notes. We have prime factors and we have prime factorization. So we've already worked with these. Now here's the vocabulary for it. So a prime factor is a number that has exactly 2 factors, 1 and itself. So we listed prime factors. We said we started with 2, 3, 5, 7, 11, 13, and it goes on, keeps on going, right? Is 1, is that a prime factor?
No.
Why not? Excellent. 1 is not a prime number. 1 is not a prime number because a prime number has exactly 2 factors, right? How many factors does 1 have? Only 1. Has everybody got that? Good. So prime factorization is writing a number as the product of the prime factors. Okay? All right, so example 2, we want to find the greatest common factor using prime factorization. Okay? Now, we can use prime factorization using the factor trees, or you can use prime factorization using the cake method.
Wait, no. Can I use
All right, so let's do the cake method. We're going to use the cake method. We're going to find prime factorization to find the GCF. So we're looking for prime factorization, and we're looking for the GCF finally, and we're using 120 and 300. Is everybody with me? All right, so here we've got 120 and 300. So what is a prime number that I can divide into 120 and 300? We could do 5. We could do 2 also. I'm going to start with 5 because that's what he started. In my video, I started with, I started with 5. You could start with 2 if you wanted to. So 120 divided by 5 is, so that's going to be 24. And 300 divided by 5 is 60. Very good. Okay, so there's my next layer. What can I divide by next?
2.
Okay, let's do 2. 24 divided by 2 is 12, and 60 divided by 2 is 30, right? There's my next layer. Can I divide by another prime number? I can do 2 again. So 12 divided by 2, 6. And 30 divided by 2, 15. And there's my next layer. And now what can I divide by next? 3. 6 divided by 3, 2. And 15 divided by 3, 5. Can I divide by any other prime numbers? Nope. So we are done. And to get our greatest common factor, there is what we will multiply. So the greatest common factor, the GCF, we will find by multiplying 2 to the second power times 3 times 5. So 2 times 3, 2 squared is 4. That's 2 times 2. And then 3 times 5 is 15. And 4 times 15 is 60. So the greatest common factor between 120 and 300 is 60.